Today we represent HCMUS team at in this task to represent their work. So first, the method they approach for this problem is that they have two approaches. The first one is that they try to find the relationship between other attributes in the provided data, such as temperatures, NO2, O3, or humidity, related to PM 2.5. And the second approach is that they try to use the PM 2.5 values from other people in the same group to infer for the missing one. So in the second approach, they propose three another enhancement to update to improve the result. So the first approach, here's the model of the first approach. So they simply combine the data from temperature and humidity of the users from other groups, from other people in the same group, and then normalize it and put it and feed it into a fully connected network to predict the PM 2.5 score of the missing one. So in this task, the run one of them, they try to train this network on the test data and then infer for the missing one. For the run two, they will try to train it on the development set first and then use it to predict the missing one in the test set. So the approach choose is originated from the observation that in most cases people in the same group go along the same route on the same day. So with that observation, they propose to predict the missing PM 2.5 values from other PM 2.5 value in the corresponding times. So they show it, and they have a visualization about the graph that every second and every minute the people will tend to go along together in a route in the same route. So it's reasonable to infer from the PM 2.5 values of the same people. So the first one is that they try to average change the PM 2.5 values of other people in the same group at the corresponding times. That is for each moment, for each minute, or for each second. They will averages on other 2.5 values from other people and infer for the missing one. So that's the one problem here is that the gap between the recorded values is around 1 minute or 1 second, which is different for other people in the group. So they try to infer for all the missing values by using one-dimensional convolution, one-dimensional linear interpolations, and then they from that missing value, from that predicted value, they try to average them and fill in the missing value of the target one. So for the second approach, they have some observation that there's a bias factor here, that the consistent is different between the true values and the values recorded by other device. There's some error that the device might have. So in order to do that, they will try to compute the bias values, that is the standard error of the device, and then plus it into the result of the run 3. And this is the result that they submit in run 4. So in run 5, they notice that there are some outlier values, such as you can see that in the graph, there are sometimes that the graph is moving up and down very gradually, but there's some point that this is very abnormal, that the peak of the value is very high. So they propose to remove the noise and outlier first, and then try to apply the approach from run 4, that is here. Try to apply this again and put a threshold to remove the outliers and compute the average for that. So the run 5 is that the main idea is that they remove the outliers and apply the same way in the run 4. So they only attend in the first task, in the first subtask. So the best one is the one that they use the average with bias, that they observe and include include the bias value into the result. Yeah. So if you have any questions, please write on Google Docs so that I can answer you directly. Yeah. Thank you.